Okay, so we ended up at the end of problem 57. We just didn't have enough time to finish it up. So by all this simplification here, and again, this is just algebra stuff, which is good for you to work on. It's only going to help you in the future. But we can cancel those 2's there. And we would end up with negative 1 over x plus 1 times x minus 1. And I would leave it in factored form because we can tell easily where that derivative is not defined. It's not defined at x equals negative 1 and x equals positive 1. Alright, so we'll go on to the next set of problems. Okay, I'm going to stop with this set at number 59. I think that's plenty of enough of this. The other ones are just really complicated and complex expressions to work with. We're looking for the derivative of the natural log of a quotient again. So I'm going to rewrite that as the difference of the natural log of square root of 4 plus x squared and natural log of x. And all we did there is apply the properties of logs to that quotient. The log of a quotient is the difference of the logs. Now I have the natural log of square root of 4 plus x squared, and that's the same as 4 plus x squared raised to the 1/2, so we can still bring that 1/2 down. And so we end up with 1/2 times the natural log of 4 plus x squared minus the natural log of x. And the 1/2 only applies to the first term. It's because it was the square root of 4 plus x squared. It doesn't apply to the natural log of x in the second term. Alright, now we're ready to take the derivative of that expression. And when we do that, the 1/2 is a constant multiple, so that stays. And the natural log of anything is 1 over that thing. But then we have to multiply that by the derivative of that inside function, and the derivative of the inside function is 2x. And if I want to, I can write that as 2x over 1. Now the derivative of natural log of x is just 1 over x. When I simplify a little, those 2's cancel, and I get x over 4 plus x squared minus 1 over x. And I really do want to make this into a simple fraction, because then I can find out where it's 0 and where it is not defined very easily. And those are the two most common things that we want to do with the derivative, and we're going to get into this a lot in the next section, the next chapter, and that is find out where the derivative is equal to 0 and find out where the derivative is not defined. So in this case, I'm going to take the first term and multiply it top and bottom by x, and the second term multiply it top and bottom by 4 plus x squared. So the first term will give me x squared over x times 4 plus x squared. And the second term will give me minus 4 plus x squared over x times 4 plus x squared. Now we can combine the two over the common denominator, but you have to remember to apply that negative sign. Excuse me, you have to apply that negative sign to the whole expression, 4 plus x squared. So it's going to be minus 4 minus x squared. And the two x squares are going to cancel or going to zero out. And in the end, we have negative 4 over x times 4 plus x squared. You can tell where that's going to be 0. It will never be 0 because it's only 0 when its numerator is 0. The numerator is never 0. It will be undefined whenever its denominator is 0. And you should note that it will only be undefined when x is equal to 0, because 4 plus x squared is never 0. Whatever number we put in there, negative, 0, or positive, will come up with a positive expression. So that's the end of that example. Alright, so that's all I'm going to do for this particular set of problems. I'm going to go on to working with the exponential functions in the next set of videos.